This video tutorial looks at the mathematical strand of linear and non-linear relationships, and more specifically we're going to focus our understanding on graphing linear relationships using a gradient and a y-intercept. Now previously in mathematics, when you would have been asked to draw a linear relationship or an equation, a linear equation, you would have been asked to construct a table and discover a set of coordinates through substituting. And then you would have plotted the coordinates from the table to form a straight line. So for example, our first coordinate that we've got in our table would have been -2, -5. And then we would have had -1, -3, 0, -1, 1, 1, and 2, 3. So essentially you're plotting these coordinates here, and that would have given you a straight line. But we're now going to explore something a little bit different. So we're now going to talk about a bit of a new way to draw a linear equation, okay, or a linear relationship, especially if it is in the gradient intercept form. Okay, we know the gradient intercept form is y equals mx plus c, where m is our gradient, okay, or slope, and c is our y-intercept. So essentially what we need to do is we can use m and c, or our gradient and our y-intercept, to construct lines. First thing we need to identify is the y-intercept. So I'm going to use this example of y equals 3x plus 1. I know my y-intercept is 1, or plus 1. All right? And I know my gradient is 3. Now, just to recall, the gradient is the rise over the run. So it goes up 3 and across 1. Up 3 across 1, up 3 across 1. If I'm going to go back the other way, I go down 3 and to the left 1, down 3 and to the left 1. Oops, let's just fix these. So it's up 3 across 1, up 3 across 1. And you can see that I've now got my points that I'm drawing for my line, simply just by identifying the y-intercept and the gradient. Let's use a different color. Let's use light blue, and I'll do the same for my second equation. The y-intercept is -2. So I know that my graph is going to be crossing over at -2, and I know my gradient is -2. Now the gradient is the rise over the run again. All right, or the vertical displacement over the horizontal displacement. So if it's going to be -2, I just need to go down 2 this time and across 1. Down 2 and across 1. Or if I go up 2, I now go to -1. Up 2 to the left 1. Up 2 to the left 1. And you'll see that we're starting to get a straight line here, where our equation of that line is y equals -2x, take 2. Okay, so let's have a look at some example questions here. My first equation, I've got y equals -2x plus 3. I know 3 is my y-intercept, and I know the -2 is my gradient. First thing I want to do is identify my y-intercept. Here it is. The gradient is -2, so it's very similar to what we had last slide. So we go up 2 to the left 1, up 2 to the left 1, or we go down 2 to the right, down 2 to the right, down 2 to the right, and you can see that these red dots form a straight line. In my second equation, I'm going to use green for this one. I know my y-intercept is -2, and I know my gradient is 3. So I find -2 on the y-axis as my y-intercept. And I know the gradient is rise over run. So this time I'm going to go up 3 and across 1, up 3 and across 1, up 3 and across 1. Or if I go to the left 1, I've got to go down 3, and we can see there's our straight line graph of y equals 3x take 2. Okay, so here's a pretty simple question I'd like you to have a go at. It basically says which graph below, graph A or B, shows the line y equals 2x take 2. So essentially find the y-intercept, make sure you know where it is, and then determine the slope to work out if either of the graphs actually show the equation y equals 2x take 2. Please feel free to pause the video. Once you think you know, continue on and we'll check and see how you went. Okay, so let's see how you went. The answer was graph A, okay, and we can see that because we know our y-intercept is -2, okay, and therefore this line crosses at -2, and we know the gradient is 2, and obviously this goes up 2 and across 1, up 2 and across 1, up 2 and across 1, up 2 and across 1. All right, so there, graph A.